in we have started the unit 6, general process of isolation of elements, and there we have discussed about the introduction part of it, and also we have discussed about some of the terms that we use: minerals, ores, um, gang, and all these things. Then I have told you also how you collect the ores, and after that how do you go for its purification. So in purification we have discussed about the physical methods of purification, where we have discussed about the gravity separation. Again, gravity separation depends upon the specific gravity of the metals and the ores. The metals where you find it is heavier, then we try to wash it with running water. And if the metals are lighter, in that case, we put that ore powder into the tank and we uh, stir it with a propeller with where high pressure air is being sent, and we find the lighter ore is comes to the top of the tank and overflow. Then we have discussed about the magnetic separation. Magnetic separations, anyway, it is not being done for all types of ores, though only those ores which are found to be magnetic in nature we do it. Then we have discussed about the froth flotation process. I told you is very important for exam. Froth flotation process depends upon the degree of the wettability of the ore with well between well and water. And we have also discussed that the froth flotation process is specifically done for the sulfide ore. And also I have told you, suppose the ore is a mixture of two sulfide ores, how do you separate them? We use the depressant. In case when you use depressant, one of the ore reacts and that compound which forms on the coating of the ore, it absorbs water and become heavier and sink, and the other ore which does not react, it floats, uh, comes to the comes along with the froth overflow, and after that again we get back this other ore by using an activator. Then we have discussed about the chemical separation. Chemical separation, I told you the process is called leaching, where the ore is being treated with certain compound which on reaction with the ore forms a substance which goes into solution. So the impurities are being filtered and we separate them in the form of residue. And there we have done one example uh, of the purification of alumina, all right, where we have treated the alumina with, not treated, we have heated the alumina with concentrated solution of sodium hydroxide under high pressure and temperature. And by that way, the alumina reacts with sodium hydroxide and forms water soluble hydrated sodium metaaluminate. And even though the portion of the sand gets dissolved, but when we raise the pH of the solution, so after that we filter it, and the filtrate pH, when is being increased by either dilution with water or with passing or by passing carbon dioxide, we find selectively on the alumina comes out, sodium silicate remains in the solution. And that wet sodium silicate, whatever we get it, we ignite it at 1473 is a pretty high temperature, and by that way we get 99% pure alumina. There, that process is called Bayer's process. That in that process that we have discussed it with you is called Bayer's process. So for examination purpose, it is very important. They may ask you, write the Bayer's process of purification of alumina. All right. Now here I want to tell you something about our entrance exam. In fact, you know, we have two types of bauxite ore. One is called gray bauxite, other is called red bauxite. This method is being used for purification of the red bauxite. Red bauxite contains impurities in the form of iron. because ferric oxide, or we call it red hematite, it that presence of hematite Fe2O3 imparts a red color to the bauxite. Because of that, you call it red bauxite. So the red bauxite is being purified by the process of by the Bayer's process. And another type of ore is there, we call it gray bauxite. Gray bauxite does not contain iron oxide as impurities, but it contains plenty amount of sand, silica, and that makes the ore little gray in color. So the gray bauxite is being uh, purified. Again, here also we go for leaching. In that case, what we do, we use a method called Serpek process. Serpek. The pronunciation and spelling is different, so this is only for your entrance exam. I'm not going to discuss here Serpek process. Now, primarily the leaching is being used for the purification of gold and silver. See, silver we get it in the form of, sorry, gold and silver we get it in the native state. Native state means uncombined state. But huge amount of silver is also found in the form of silver sulfide. Sulfur sulfide. Okay. So now I'm going to tell you how to purify. First, I'll do the purification process for the naked silver and gold. Second one is called the leaching of gold and silver. I write here native. Native means uncombined. See, abundance of silver and gold in our earth crust is very less. Suppose if you have taken 100 kg of the mud, if you get there 100 gram of gold, then you would know that you are lucky. In India, gold was first struck in Karnataka, a place called Kolar gold mines. Kolar. So there, later on, this gold mine was being abandoned, and it is Kolar gold mine has the deepest mine in the world. It has a depth of 5 kilometers, but only 10 gram was gold was we could get it from the 100 kg of the gold. So later on, it has been abandoned. But anyway, again the mine is being started. Why not the same mine? Nearby places they have got a gold reserve where it is still profitable. So the silver ore and the gold ore is being crushed into powder, okay, and it is treated with 0.5% sodium cyanide. The sodium cyanide is dangerous, so that extremely toxic. If it comes in contact with the blood, then people will die. But anyway, for there's a risk is there in gold, so they take the risk and do. So sodium cyanide is mixed with the in the large tank. They take 0.5% solution of sodium cyanide, then they put the gold or silver ore, and they send air under pressure, and they constantly stir. Now see what they do. So sodium cyanide will react with, I'll write M. Okay, why? Because this equation is same for gold and silver. M plus, so when you stir it, you'll get here you'll get this. Okay, so here M is equal to gold or silver. This is soluble in water. I'll write here aqueous. Okay, and rest of all the substance is insoluble in water. So you can filter it. Okay, it's a huge filtration process. So here filter is not being done by using filter paper there. They use thick canvas cloth. But the residue still will be wet, and that one also will contain gold or silver dissolved state. So what you do after the filtration is over, we wash it nicely with the fresh water. Let all the thing go to as a filter. So this is the leaching of silver and gold. Okay. Okay. Suppose if you have got wait a minute. Hello. So this silver you may get it in the form of this also. This is called argent. So that is for native silver. Native silver means uncombined silver or uncombined gold. Gold will never get in the form of salt. So this is you can get in the combined. That is called we call it argent. Okay. So here same method you can use it here. So what you are going to get? You will get here 2 Na Ag. See, you are getting the going to get the same thing. Only here it may be silver or gold, but here it is silver. So all the impurities will be insoluble and now let me finish the extraction process also here. So to the filtrate, what we'll do? To the filtrate, we'll add here. Say I have written here this. See, it is not difficult. Now to that we add there zinc. Zinc powder is being added. See, when you add zinc powder will go into solution. You know it is gray in color, and at the bottom you will find shining silver or gold is coming out. So what you get now here? You will get Na2 Zn Cn4 and 2. So here M is whether you follow this process or this process, you are going to get the gold and silver. Okay. So for examination point of view, it is very important. You know why? Because this chapter has only 3 marks. So when they give you some question, this is a big chapter. So many questions are there. So they cannot ask you a question which is having more marks. So they will try to give you small questions. See here, in this case, by giving 2 marks, you can directly get silver and gold. Okay. So this method is called MacArthur forest cyanide process. Okay, please don't think that this person has done this extraction in the forest. Forest is his title. MacArthur Forest. So, So now we have done even also the bleaching process. Okay, now see here. What are the things you have done it till now? I told you, no, you think that it is your factory. So what are the things you have done till now? You have identified the place from where you are going to get the ore. So you have sent your men. You also have gone there. Then you have done the mining. After mining, you have collected big rocks or even some stones, hard masses. You have broken it there itself into fine powder. Then you either you have loaded in train or you have loaded in truck. Okay. How did you converted them? We have converted them by using some machines, and that process is called pulverization. After that, you brought to the factory and you have sent a sample to your chemistry laboratory. They have found out the chemical and physical nature of the ore and the impurities. Then the chemist is going to suggest you whether you should go for physical process or chemical process. If it is a physical process, you'll, based on specific gravity, you'll go for gravity separation by washing with water. If you find the ore is magnetic in nature, or if the ore is magnetic in nature, you will go for magnetic separation. Okay. Or if you find this that your ore is a sulfide ore, just like see here also I have written silver sulfide. Okay. So in that case, you will go for froth protection process. And if the person in the lab they told you that you have to go for leaching, then they itself will tell you that what type of substances you should use. Like in case of aluminium, the chemist told that please use sodium hydroxide. So we have used sodium hydroxide. In case of gold and silver, it is being told that you should be done with sodium cyanide. So we have done sodium cyanide. So by that way, major portion of your impurities is being removed. Please remember, in leaching, almost 100% of the thing is being removed. Okay, so it is being removed. Now we'll go for, because see, by the thing that you have got till now, our ore, whatever ore the treatment we have done, our ore is wet. So we have to dry the ore. Just a minute. Yeah? So now we have to go for drying the ore. So there are two processes. One you call it calcination, and second one is roasting. Now what is calcination? This is our heart. Calcination is, it is the process of heating ore in absence of air or in limited supply of. So by this process, what you get? See, by this process, one, the wet ore becomes dry. It is water goes out and heating is done below its melting point. Heating is done much below its melting. Second, the carbonate and bicarbonate ore become oxide. See here, suppose I have taken here zinc carbonate. If you heat it, then you get here zinc oxide, carbon dioxide. So this is our Cherrapunji Sora. Okay, limestone is there. If you heat it, you get here calcium oxide and carbon dioxide. And third, the ores become perforated. What is the meaning of perforated? Because when the gas comes out, the ore, just like when you bake the cake, what happens? In that case, lot of holes are being created. The holes also get lot of holes. So that it is easy for us to go for reduction. Okay. So this is called calcination. Write down. Yeah, go with me. आगे जानले तो क्लास में क्लास तो আগত আগত কিয় নকৰিলি তেতিয়া ক্লাস আৰম্ভ হৈ গ'ল তেতিয়া মই কেনেকৈ কৰিম? So now have you written?
Yes, sir.
Okay. Now we'll go for roasting. না না আমি তো এখানে আমার কাজ চলছে সুবিধা আছে। Now we'll go for roasting. In this process, ores are heated in presence of excess of air below its melting point. See, in case of what is the distinction? Distinction often comes. What is the distinction between calcination and roasting? calcination is done in absence of air or small supply of air. In case of roasting, it is heated in presence of excess of air. In case of calcination, heating is done much below its melting point. In case of roasting, it is done just below its melting point. These are the two differences try to remember. Okay. In this process, the ore get oxidized. Generally, sulfide ores are roasted. Please remember. Okay, now I'll tell you a simple way to remember the equation. It's very, very simple. Anyway, so first I'll write. What are the things happen? In this case, what happened? The wet ore becomes dry because you are heating it, becomes dry. Second, the sulfide ores get oxidized. Say, I have taken here zinc sulfide and oxygen. It will give you zinc oxide and sulfur dioxide. See, simple technique. With closing your eyes also you can write. Here we will write 23 and here we will write 20. Later on you see whether I am wrong or right. Okay. See the balance. Zinc sulfide, whenever you go for zinc, it is there in your syllabus. We use zinc sulfide ore. Okay. Its technical name is zinc blend. Zinc. Then copper. Okay, we call it copper pyrites. All this thing I'm going to discuss. Copper pyrites. Okay. So now you try whether I'm right or wrong. You check. What do I tell you? 2, 3, 2, 2. Please compare there whether I'm right or wrong. Check. Count the number of atoms left hand side and right hand side. Tell me whether I'm right or wrong. Is it balanced? Check left hand side and right hand side. 23, 22. You have not checked. Very good. Now see, this is not in your syllabus, or this ore is called galena. See here. So please don't break your head. Okay. Chemical equations are not difficult. You should know only the technique. 23. And what is the third one? The ore become porous. The ore become porous. So I know you will not say anything. This habit you could not overcome to speak in the class.
So the second equation is still not balanced.
See, which one is second one? Okay.
Yes, sir.
Okay, see. 2 into 2, 4. 4. Okay. 4 no? 4 copper. Left hand side 4. Right hand side 4. Sulfur sulfur কেন দিলি আর মো কোনে কেন sulfur 2
2.
copper is valence sulfur is valence oxygen how many here
4.
4 okay oh no sorry I have this I made the mistake no it will be 3 23 22 no see 3 into 2 6 and 2 into 2 4 plus 2 6
6.
balanced
Yes, sir. It's okay now.
now acha now you have understood what is the equation of roasting or fly or fire 23 22 okay will you forget
No, sir.
very good okay now see here so our we have come a long process right from the ore we could purify the ore and we have after purified we have dried the ore and in case of sulfide we are got it oxidized now I have to get my metal see metal we have got it in the form of metal oxide I'm not writing this equation whether it is MO or M2O or MO2 what I'm supposed to get I'm supposed to get M from here then what I'm supposed to remove I have to remove oxygen oxygen itself will not go so let me talk of little bit of thermodynamics I told you M plus O that is 2 O2 immediately forms 2M immediately in the nature see if you keep iron article outside does it not get rust by itself you don't have to go and request please rust huh so this process is what this process is bonding that is delta G is negative what we are supposed to do we are supposed to do get from here M plus O2 see if this process is spontaneous reverse process is non-spontaneous so this is non-spontaneous so here what you will find here delta G is positive but we know if I have to get I have to make delta G negative so how will you do see we know delta G is equal to delta H T into delta S all right T into delta S so in this case how can you make this delta G negative see very interesting let us take the example of this delta S see it is in solid form in solid form the whether any molecule cannot move ore is a solid substance it cannot move so in that case delta here S is here is very less if I have to make this one this thing negative in that case this value should be more than this value is a negative value so product of this whatever the product will get if this product increases then with the negative sign before then this thing also will increase so when it will be this will be possible only when T into delta S become more than delta H okay temperature is in your hand but you cannot raise the temperature to infinity you know why suppose you are cooking something in pressure cooker can you heat the pressure cooker above the melting point of pressure cooker is it possible if you supply too much of heat the pressure cooker will melt then how will you cook it is not possible so what you can do When you start heating this one, the ore will melt. When the ore will melt, then ore will start flowing. When it starts flowing, delta S increases, entropy increases. So in that case, your extraction can be done by heating the ore to high temperature when the ore starts melting. But mind it, when you are supplying heat, delta H is positive. When the heat is supplied, delta H is positive, and and when the heat is being released or getting cooled, delta S is negative. So when you are heating it, this value increases. This value increases, but this value increases. So you have to heat it at very high temperature. I told you there is a theory is something and practical is something. So we cannot heat it up to infinity. And moreover, this is not cost effective because when you want to heat it, you have to burn something. It's a fuel. It can be carbon fuel or it can be electric fuel. So in that case, what is going to happen? For carbon fuel or electric fuel, you have to spend huge amount of money. All right. So this is not. This is done. This is done for what type of substances? This is been done by those type. We heat those type of substances which get easily decomposed. Who moment you heat it, it get decomposed. So that oxygen is set free. Moment oxygen is set free in the form of oxygen gas, in that case, what happens? Entropy increases tremendously, and this type of substances can be obtained. So there are very few substances like this here, whereby heating it not to a very high level, you can convert their oxides into metal. They are silver oxide and mercury oxide. Others are not. Silver oxide and mercury oxide, if you heat it, it becomes metal. See, suppose say you are having a silver ornament. Because of wear and tear, you find that this ornament has becoming dark. Why? Because this silver somehow came in contact with some oxidizing agent. Silver cannot be directly oxidized by oxygen of the air, but it has come to a strong in presence of strong oxidizing agent. In that case, silver will form silver oxide. Silver oxide is dark. You go to a jeweler. What you will do in front of you? You'll put your silver chain or ring in the fire and you blow air. Temperature there is not very high, maybe 600 to 900 Celsius. In that case, what happens? Silver oxide breaks down. Silver remains on your ring or on the chain. Oxygen goes out, and he'll take it out and brush it, and he'll do it twice or thrice. See, here the chemistry lies. This is this. But if it is not cost effective, we will not go for this one. Then what we'll do? We find, suppose you have taken here MO, okay? Here M plus, I'll write here half O. Delta G is positive. But suppose I have taken here carbon and I have taken here oxygen. We know that carbon immediately burns in presence of oxygen and is highly spontaneous. It will give you carbon monoxide. Or carbon plus oxygen, it gives you carbon dioxide. In both the cases, delta G is large negative, delta G is large negative. Okay. See, now let us forget about this. If I do both the reaction in the same pot simultaneously, what is going to happen? See here, this and this. So what you get now here? MO plus C becomes M plus CO. As this value is large negative and this is small positive, ultimately what you get? You'll find this. So this reaction is called coupling reaction. Coupling reaction. When you cook a curry, why do you put salt there? because salt makes your vegetable softer. So you have to heat it for a long time. So it is a coupling reaction. So similarly here also, we'll go for coupling reaction. So when you go for coupling reaction, in that case, you find your process become easier. So what has carbon has done? Carbon has removed oxygen from the metal ore. So is it not reduction? Yes, it is reduction. So this process is called reduction of ore. So reduction you can do it by two ways. One is thermally, and second one is through. Second one will do it through by coupling reaction. The entire thermodynamics that I have discussed, it is given in your book in the form of Ellingham diagram. Do not get scared by this graph, Ellingham diagram. Okay. In Ellingham diagram, what they have given in the chart, what is they have given? They have given this value. They did not give this value. But here you will find two graphs are there. One is the carbon monoxide and other one is carbon dioxide. Both we can use carbon monoxide as a reducing agent. If I use carbon monoxide as a reducing agent, see here, if I use carbon monoxide as a reducing agent, what will get? We get here carbon dioxide. So both carbon monoxide and carbon dioxide are used as a reducing agent. But one condition is there. What is the condition? If the reduction temperature is below 1000 Kelvin, if you want to find in centigrade, you subtract 273 there. That is, say it is below 850 degrees Celsius or 1000 Kelvin. In that case, we use carbon monoxide. And if the reduction temperature is above 1000 Kelvin, in that case, we use carbon. Okay. So please excuse me, today in my house, some guest has come. My niece has come. She has got a position in class 12 also. She came to meet me. So I have to be with her. Okay. So please don't mind. I shall, and moreover, this reduction, all the reduction I'll do in one day. So today, if I start, I'm not going to finish it. So please excuse me for today. So I shall meet you on Saturday. Thank you.
Bye, sir.
Thank you, sir.